This conference will now be recorded.
Hello, everybody. Thank you for joining us for the Satellite Book Club seminar series. This is session number 98. The title of today's presentation, GOES 18 ABI Update and Plans Moving Forward. And this is timely as GOES 18 is moving towards the GOES West position. So really exciting time. Our presenter, Tim Schmidt, the GOES-R Algorithm Working Group Imagery Lead. I'd like to remind everybody to please join us to celebrate the 100th session of the Satellite Book Club. It takes place 2 weeks from today on June 2nd, 2022 at 11 a.m. Eastern Time. There's going to be a new time for that week only when Brian Curran and Devin Chehek from WFO Midland, Texas will revisit a May 2021 tornadic supercell. And I just wanted to check to make sure that everybody can hear me because I heard that somebody, oh, okay, we are still all good here. All right, just a few reminders before we get started that this presentation is being recorded. There will be an opportunity for Q&A after the presentation, so we encourage attendees, particularly from forecast offices and the regional headquarters, to post their questions in the chat room, and we'll field them that way. We encourage attendees to sign in with their full name or specify your full name when asking a question in the chat if you're using that office account. That'll help us get back in touch with you. We're also looking for future presenters. So if you have something that you'd like to share, or maybe just a discussion topic that uses satellite data or satellite and other data, please get in touch with our TowerS team. We'd love to have you. Or if you're looking for training materials, the training team can help create materials that may be unavailable. Please contact Brian Mata for information or questions regarding that. I'd like to thank our TowerS team, particularly Kashad Bowman, the Office of the Chief Learning Officer, the GOES-R JPSS program, and our facilitator for today. Without further ado, I'd like to introduce Tim. Tim works at the Advanced Satellite Products branch within the NESDIS Center of Satellite Applications and Research, STAR, in Madison, Wisconsin. Tim had a lead role in the band selection for the ABI on GOES-R. Tim has played a key science role during the on-orbit checkout of GOES 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and now 18. I guess in the bio, they didn't want me just to say 8 through 18. Tim has published over 100 journal articles, several book chapters, and co-edited a book, all associated with some aspects of GOES. Tim received his master's degree from the University of Wisconsin-Madison, and I'll just add tweets with the handle @GOESGuy. So you are getting the guy that knows GOES here today. It is my understanding that we also have Dan Lindsay, the GOES-R program scientist, standing by, and Frank Ulsheimer, the Science and Operations Officer from the National Weather Service Forecast Office in Columbia, South Carolina, to help facilitate some of the discussion afterwards. So, Tim, welcome to the Satellite Book Club.
All right, thank you very much, and thank you for the kind introduction. So let's go on to the second slide. So yeah, thanks to all my co-authors, and thanks to all of you. As was stated, First Light Imagery is out. Here's some links to see either some blogs or the official video that came out, the Earth from orbit. So a lot of good news. Going to go on to the next slide. So, this is the video itself, and again, stunning, wonderful. We run out of words to say with the first light imagery. Recall, we're kind of on an accelerated schedule. This was just launched, March 1st, and had a successful first part of the post-launch test. As Jordan mentioned, it's now moving over to the near west position for the second half of the post-launch test. But the images have been remarkable. I'll say GOES 16-like, which is a high praise. Of course, it's still early on. I just want to get out of the way. GOES 18 imagery, preliminary and non-operational. You can see here the beautiful water vapor images through the day. Here's some images from AWIPS itself, you know, visible with the overshooting tops, etc. Fog over South America, a Vis-IR sandwich combination. Just a lot of just phenomenal imagery, smoke, dust from the ABI. Just really remarkable. Another view in AWIPS there, visible with warnings, suspended sediment. Another view of South America there. So again, just really remarkable image wherever you look on the globe. You know, clone, so we get you know, 10-minute full disk, 5-minute CONUS, and the 2 mesos at 1-minute data, or as often as 30 seconds if they're overlapping regions. So I just want to thank everybody who put that video together. It's out there for sharing, and Dan put a link in the chat. So next slide. So again, what we'll talk about today is some of the early comparisons. So compared to 16 and compared to 17, bottom line, very good qualitative image agreement. Of course, it doesn't agree with GOES 17 in loop lead times because the issue with GOES 17. You know, there's still improvements planned with navigation, calibration, etc. So it's an exciting time, and things have really so far qualitative look very good at this early stage that we're seeing. Okay, next slide. So here's 16 panels, 1 through 16, GOES 16, been remapped, and you flip between this and the next one, then you'll see GOES 18. So and then you flip back. Of course, you don't expect them to be exactly the same. View angles are different, parallax is different, but you can see very similar look. So that was GOES 16 versus GOES 18. And now if you flip forward again, then you'll get to GOES 17, and then go forward again, and you can toggle between GOES 17 and GOES 18. Of course, you know, it's a big view difference on the East Coast, but you know, you can see by just looking at these multi-band comparisons that they're very similar, what we're getting. Okay, if we go on to the next slide. So now we'll do a comparison, GOES 18 versus 16. This is at the anomaly 18Z. So go on to the next slide. So here's band 1, obviously over Florida. I think if I didn't have these labeled, you may not be able to tell, but in this case, GOES 18 is on the left, GOES 16 is on the right. Go on to band 2. There's some indications maybe band 2 is a bit bright yet, similar to the previous ones, but again, by just looking at images, it's hard to tell. They look very similar. Go on to band 3. Of course, the veggie band really stands out. Again, very similar. Band 4, the Cirrus band, you've heard it before, similar looking, 18 versus 16, which is really saying something. Band 5, so we get into looking at the snow ice band, and similarly to GOES 6. So that's it for the visible near IR bands. Now if we flip to go next band 7 to 3.9, again, very, very similar that you see in this comparison between 16 and 18. Let's go on to the water vapor bands. So band 8. So again, even if you look at the you know, those little overshooting tops, the colder pixels in this enhancement, they're black. In the panhandle of Texas there, you know, 3 overshooting tops in GOES 16, 3 cold turrets there in GOES 18. And the gradients you can see very, very similar as well. Let's go on to band 9, mid-level water vapor band. Same story there. Clouds look very similar. Moisture gradient looks very similar. And we've gone to the low level water vapor, band 10, again, very similar what we see here. Let's go on now to the some of the window regions. So band 11, again, same story. Let's go on to band 12, ozone sensitive band, colder due to the absorption of ozone. Again, very, very similar as one would hope for. Back to band 13, a window here. Again, very similar that you see versus 18 versus 16. Next slide. Same story, 14. And then we go on to the dirty window, band 15. And finally, band 16, the CO2 sensitive channel. So again, GO 16 is a great instrument to sort of look like GO 16 is really what you want. On to the next slide. So now we'll compare to GO 17 versus 18. We'll first start at nominally 18Z. So again, band 1, the 0.47, if you just looked at these two bands side by side and they weren't labeled, you'd probably hard to tell which one's which. Go on to the 0.64, traditional red band. Again, hard to tell with the imagery if the 18, which is now on the right. So in general, you know, hard to tell if that's actually brighter. The calibration work group will be looking at that closely, comparing to a lot of other measurements. But again, for qualitative sense, you can see a very good agreement for the visible red band 2. We go on to the near IR bands. So the veggie band 0.86, very similar looking imagery. The Cirrus band or band 4. We go on. Again, you know, very similar as what we would hope for. Band 5, you've heard the story before, very similar. And just a reminder, goes 18, preliminary non-operational. Band 6, and again, now we'll go on to the IR bands. So here's band 7. You know, again, very similar, especially once you remap them here. Let's go on to band 8. So remember, this is 18Z, so not so much a loop heat affected time for goes 17 on the left there. But again, you can see the wave phenomena there on the border of California and Nevada in both the 18 and 17 views. Going to band 9, mid-level water vapor. Again, I think those maybe stand out a little bit more in 17, but again, you don't expect water vapor to look exactly the same as you're looking at different view angles. Of course, the more opaque bands, water vapor, ozone, CO2 are most affected by the view angle differences. Let's go on to band 10, lowest level water vapor. Again, very good qualitative agreement. We're going to go on to band 11 now. So we can see a good agreement. Let's go on to band 12, the ozone band. Good agreement. Band 13. Now you can see there's a little bit of issue with the navigation and registration for this time on goes 18. That's a known issue, and will be addressed. Band 14. Same story with the INR navigation, but again, good qualitative agreement with the imagery. Let's go on to band 15. And then band 16, the ozone sensitive, CO2 sensitive band. All right, so if we go on to the next slide, now we're going to do this again, but now we're going to do 14Z for GO 17. Go on, band 1, fine, similar, a little bit darker overall, both of them. Band 2, again, similar. 3, band 4, band 5. Of course, it gets a bit more interesting when we get to IR, band 6. Band 7, not affected by the loop heat pipe, band 8. And you can see they're affected, but goes 17 on the right, but not goes 18 on the right. Let's go to band 9. Same story, band 10. Again, the one on the right, we need to label preliminary non-operational. Let's go on to band 11, band 12. Again, a very affected ozone, a band for loop heat pipe, band 13, band 14, band 15, and band 16. So again, 16, you can start to, again, you can see the noise in the banding and go 17, which isn't there in 18. So yep, let's go on. Now we'll do some 3-panel comparisons. Go on to the next slide. This is 4 micron and in the native projection. So goes 17 on the left, goes 18 in the center, and goes 16 on the right. So again, of a hot spot along California there. In this case, 17 was, some of my different timing, but again, good qualitative agreement. Let's go on to the next slide. We'll do that again, but now over the fires, red and black highlighted the hottest. Again, it goes 18 there in the middle. Again, we don't expect the exact same answers, but you can see how remarkably similar these are. Not too bad for an instrument, almost 1/10 of the way to the moon. Go on to the next slide. So there are more comparisons at this satellite blog. You can look for loops of all the bands, not just a couple of time frames that I showed here. Let's go on to the next slide. So here, yep, so these are some of the, for example, sample loops that are on that blog. This happens to be band 10 for 17 versus 18. But we have them there for all 16 bands for both compared to 18 and 16 and 18 to 17. Go on to the next slide. So point here is GOES 18 joining the pantheon of the GOES. GOES 1 from 1975 to now GOES 18. Go on to the next slide. Again, launched as GOES T, renamed GOES 18. It just finished part 1 of the post-launch checkout from the center location and is currently drifting to near 137 west, scheduled to arrive on June 6th, and then imaging starting with the ABI on June 7th. No ABI data during the eclipse. During the 2 heat pipe times, in August and mid-November to mid-November, GOES 18 ABI data will replace the GOES 17 ABI data in the operational flow. We're calling this interleave. There's been some tests so far. So again, if you're pointing to GOES 17 during those times, you'll get GOES 17 GLM, but you'll get GOES 18 ABI. The bottom link has the transition to operations plans. So starting in mid-June through the transition, GOES 18 ABI will be available for supplemental ops and AWIPs via the terrestrial data feed, and you can set that up via the tower RPM if you're interested. Then the plans are for GOES 18 to replace GOES 17 as the operational west sometime in January of 2023. So let's go on to the next slide. Here's a sandwich, GOES 18 from over the weekend and 30-second data. Visible and near IR stitched together. Again, very impressive view of these storms this early in the game. Go on to the next slide. So here's the last one showing true color imagery during the day and just a IR window grayscaled during the night. So with that, I'll take any questions. Dan's also on the line for the hard questions. And thank you so much for your time.
Thanks very much, Tim. I know that most, if not all of us, having lived through the loop heat pipe issue of GOES 17, are very excited to see GOES 18 up there and ready to pop into our AWIPs in the not too distant future. I'd like to encourage everybody to please stay on the line as we go through the question and answer section. Make sure if you have a question, please to mention your full name. Another item is in the chat window. If you look, there is a survey requesting feedback on these SBC sessions. So please, if you have the time, click on that and fill out the survey. We really appreciate all information. Next week, we'll have Justin Schultz, who's from the WFO in Duluth, Minnesota, and we'll be discussing lakeshore flooding across western Lake Superior. That picture that's in the image there looks about the exact opposite of what's going on down here in Columbia today, with it getting up into the upper 90s. And then finally, if you have any questions regarding anything that you saw here, if you have any questions for configuration of satellite products or anything, we've got a great Tower S team. Please reach out to John Evans and Lee Biberly for any support. You can see their emails on there. And then if you have any specific comments about the SBC itself, please contact Kashad Bowman. And the Tower S group is in the NWS chat room, Tower S. Having done a little bit of housekeeping here, I'm gonna start asking questions. If we got any from the group here, what is the plan for GOES 17?
So the plan for GOES 17 after 18 becomes operational is to move back to 105 West and be the on-orbit backup.
Okay, and sort of a follow-up to that is what happens to GOES 14?
I'm not sure. I think that's going to be the backup to the backup for at least for a while until it goes U, but I'm not sure. Maybe somebody else knows that more detailed.
I don't know if Dan might have an answer to that or not.
Yeah, I think, Tim, that you're correct. I can't say that with absolute certainty. So if anybody from OSPO who knows the answer for sure is on, they can chime in to say.
Any takers?
This is Jordan. I'm not from OSPO, and I'm not sure that NESDIS has released a public decision on this yet, but it is our understanding that an alternative capability for GOES 17 must be available for the same reason that we had to retain GOES 15, while GOES 17 was the operational satellite in the west position.
So it sounds like we will not be seeing it on eBay anytime soon. Okay, another question for you. Obviously, GOES 18 is what's up there right now. I know there's still one more satellite in this particular GOES series or generation, if you will. Could you explain a little bit about what the future holds for GOES U?
Yep, so GOES U is still on schedule for launching, I think, April of 2024. So same deal, launch it, basically clones as far as the Earth viewing instruments. So then that would be launched, you know, and checked out at 90 West and then on orbit spare. So we'd actually have a fully capable on orbit spare to our ABIs.
Okay, thanks. We've got in the chat, for those of you who are watching or maybe joined late, Dan Lindsay put in a link talking about the first light video that Tim showed in his presentation. So there's a link to that if you'd like to see that. It makes for sometimes some good Twitter feed or Facebook post for offices. There's also a link to some of the blogs related to it that was just posted in the chat room as well. So if you're interested in some of the blog information, and also posted in there are some links of the GOES 17 versus the GOES 18. So there's quite a bit of information in the chat if you want to click on some of those links and save them. Another question for you. We've now talked about GOES U. Is there any plans going on for, these satellites only have a certain length of time that they're active for. Eventually they become unusable. Are there any plans for any kind of follow-ups to these as we start looking, 5 to 10 years down the line and beyond?
So I guess two comments. One, as you may know, GOES 13, the Space Force is using that over the Indian Ocean now. So sometimes they have lifetime left, even when they're not operational on NOAA satellites again. There's a whole program now stood up, the GeoXO, and it's talking about the next generation, so the follow on. And then improved imager and GLM type instrument, and then a host of hopefully new instruments, including a hyperspectral IR GXS or GeoXO sounder.
That's great. So we are not resting on our laurels. The folks who are joining us who are fairly early in their careers have a lot more satellite technology and advances to look forward to. That's great. All right. Let's see. This one's not really directly a question here. Question about, remember that GOES 9 was, it's more a statement. Remember GOES 9 was stationed over the Westpac after the Japanese satellite failed before they could launch a new one. I know at some point back, I guess it was the early 90s when we had one of the GOES fail on launch. The launch vehicle had issues that we had GOES in the central position for quite a while. I'm sure some of us remember that. You might have more details on that, Tim.
Yeah, well, there are approximately 5 years that the U.S. was down to one GOES satellite. And then that kind of shifted. They shifted the location a little bit to see the storms, Atlantic a little bit during hurricane season, and move it to get a little bit more of the Pacific. So thank you, GOES 7, for lasting those 5 years. Yes, GOES G was the one that did not make orbit. And you're right, GOES 9 went in support of the Japan when they had an issue. And recall GOES 10 and 12 also spent a collective 5 years operating to support the Southern Hemisphere before we got ABI on orbit.
Okay, just to mention to all of this, there was another link put in the chat so you can click on and see some information about the GeoXO that Tim was talking about. Okay, another question from Victor Stegmiller. For September through mid-October, will the operational feed go back to GOES 17? So I guess that's the period where the heat loop pipe is not as big an issue.
Correct. So it'll GOES 17 will stay the operational west satellite, and then GOES 17 data will be flown during those non-loop heat pipe times.
Okay, thanks. Well, let me look through all the different questions. Here we got another one from Mike Stavish. Understand GOES 18 has an improvement made to the loop heat pipe to minimize the potential of another issue. Could you comment? Is every other aspect similar to GOES 17 versus the loop heat pipe?
Yeah. No, Dan, do you want to take this one or?
Yeah, I can take this one. Hey, Mike. So what happened is they changed the cooling system to a propylene-based system to an ammonia-based system, and they changed out, do something different with the filters because it was like FOD from the filters clogging. FOD clogging filters that they thought is the problem with GOES 17. So that change was the key change to the ABI itself, which now the loop heat pipes are working exactly like they should. In terms of other aspects of GOES 18 versus GOES 17, this is not so much of a weather issue, at least an earth weather issue, but they switched out the magnetometer from an old version to a new, it's basically a new vendor. It's made by NASA Goddard. And there might have been some tweaks to GLM, probably not enough to be really all that noticeable, but they're trying to make the accuracy of GLM maybe just a little bit better. And that's all I can think of. And there's one other thing to note, GOES U, which will become GOES 19, Tim mentioned will launch in 2 years, is going to have a new instrument called the compact coronagraph. And I don't know if there's any space weather people on here, but it's an instrument to look at the sun to try to get a better idea of the trajectory of coronal mass ejections when they happen. So that's something to look forward to if you happen to be into space weather for the next launch.
Yeah. GOES U also launch on a different type of rocket, which will be a change.
Yeah, we're going to go through SpaceX next time instead of ULA, so that'll be different.
Well, will it be broadcast live on Twitter then?
I would probably say that it would. I mean, I guess we can't predict what Twitter will be like in 2 years, right?
No, we can't predict what Twitter's going to be like at any time in the next 6 months, I think, beyond 2 years. But that was excellent information. Thank you, Dan. I think we've that's got all the questions. Open it up for any other. Go ahead, Tim.
I'll just add, I think there was one other question about when the satellites really do get to the end of their life, and then they're actually boosted to a higher orbit, a super synchronous orbit, or sometimes called the graveyard orbit. So all the GOES, for example, are still up there. They're just not in the geostationary orbit because they're at a higher altitude.
Okay, with no other questions, I will pass it back to Jordan.
All right, thank you so much, Frank. And I really appreciate Tim for being with us for this presentation and for all of you for joining us. Of course, thanks again also to Dan for being on the line. Just a reminder, Satellite Book Club number 99 does continue next week at the regular time, noon. Justin Schultz, meteorologist from the Weather Forecast Office in Duluth, is going to talk about lakeshore flooding across western Lake Superior. So if that's a topic that interests you, please join us once again next week. In the meantime, if you have any issues with the configuration of satellite products, the Tower S team is available to help. John Evans and Lee Byerly have their email addresses there on the slide, and Kashad Bowman can help with any questions you have about the Satellite Book Club. So once again, I really appreciate everybody joining us today, and go GOES 18. Looking forward to the future. Stay well and take care. Bye now.